Okay, we're looking at 6C. 60 is back to the water going into the tank and water going out of the tank. Bananas going onto the shelves, bananas going off the shelf. People going into the store, people going out of the store. E is the rate which they're entering. L is the rate which they're leaving. So when will it have the most bees in the hive or the least bees in the hive? Remember the overall thing, we talked about this very, very early on, and it shows up just over and over and over again. When the rate entering equals the rate leaving is when there'll be critical numbers on this. Now you can do it by taking the derivative of this, but the big picture here is if there are more entering than leaving, there's more bees going in, it's going up. If there are more leaving than entering, then the bees are going down. So when will it be at a max or a min? When the rate entering and equals the rate leaving. So now, here's the thing. We want to find out the most number of bees or the least number, hold on, least or most, I forget. That's kind of important, isn't it? The minimum number of bees in the hive, okay? So what we know, back to the, now this only has one critical number, so we could do it by relative max or min, but let's use the brute force method. Now the brute force method is check the endpoints, 0 and 4, and then I need to find the critical number. Then what you do is that, now it's going to be painful, okay? Because we're going to have to put this back into the stupid integral. Now the 0 won't be bad, and hopefully the 4 won't be bad, but the 3 is going to be kind of a pain. I don't know what's 3. That's not 3. The critical number is going to be kind of a pain. But now, when is the rate in equaling the rate out? Well, we got to do a little bit of algebra. Move everything over. 3t squared minus 18t plus 15. Factor out the 3. T squared minus 6t plus 5. T minus 5. T minus 1. So I get critical numbers at 5 and 1. Now 5 doesn't count because it's not on the interval. Thank God, because it'd be kind of a pain to do the interval at 5. So 5 doesn't count, but the 1 does. So now the good part is when I integrate from 0 to 0, you know, that's 0 and 0, right? There were 3,500 bees. Now remember, this was in hundreds, so 3,500 bees. And at time 4, I think we did that in question B. Yeah, and we did. We did that. In question B, we did it, and it was 5,500. And we did that, but we did that in another question earlier on this. So that saves time. So we're going to have to do the integral from 1. So it's going to be kind of crappy. Okay? So I'm going to have to do this. 35 plus the integral from 0 to 1 of the rate which they're entering minus the integral 0 to 1 at which rate that the bees are leaving the hive. Okay? So, so it's going to be kind of a pain here, so let's just work it out. 35 plus, what, 8t squared minus t cubed from 0 to 1 minus, and I got to be careful, we're subtracting this one, there's a negative, so it's a little yucky. I probably should have distributed in. Oh, actually, let's do that. Let's just be smart. I'm going to change this to plus the integral. I want to make this positive and that negative. Now, I'm being a bit silly here. Well, let's not. Let's leave it negative. Let's do it right. Let's do the integrals right. So I get negative t squared plus 15 halves, no, 15t. From 0 to 1. 35, put the 1. Now, the nice part, the zeros are going to be, so I put the 1 in, so I get 8 minus 1 minus 1 plus 15. So 8 minus 1 is, so it's 7. Negative 1 plus 15 is negative 14. So what's that? Minus 7, so 28. Now remember, it's 2,800. And remember what we do is this, the most number of bees is 5,500, and the least is 2,800 bees.